Hello and welcome back to Calculus 1 Exam 2 Review. We are talking about Chapter 3, Sections 3.1 to 3. Hold on. Sections 3.1 to 3.11. The chapter is on derivatives and basic rules of derivatives, plus two types of word problems. One is related rates, which is 3.11, and the other one was slope as a rate of change. We have 10 problems, and I'd say about 90 minutes for the exam. 100 points, and I believe this one is 13 or 14% of your grade, so higher stakes than exam 1.
Wasn't it like 13.79?
Something like that, yeah. So now, the concepts that will be on the exam: number 1, limit definition of derivative. This is when you find the derivative a long way using limit h goes to 0 of f of x plus h minus f of x divided by h. This problem was on your exam 1. It was worded as find the limit of the difference quotient. Now, same problem, same calculation, is just called the derivative. Then we have basic derivatives or derivative formulas. Formulas from 3.3. Then we have product and quotient, which is 3.4. We have chain rule, which was 3.7, I believe. We have implicit differentiation, I believe 3.8. We have trig plus inverse trig, which was 3.5 and 3.9 or 3.10. Let me consult the book. .5 and 3.10. Then we have logarithmic differentiation, 3.9. And finally, word problems, well, not finally, there's one more after word problems. The word problems, derivatives as rate of change, so 3.6 and 3.11, which are the related rates. And there it is, number 9, tangent line problem, which is all sections, because that depends where your derivative comes from. Technically, if you look at this list, you almost have 10 problems right there. 2 word problems on number 8. So the word problem on related rates, and then the word problem on either velocity or business with the cost analysis, all that stuff that we did in 3.5. No, 3.5, 3.6. So technically there's your list of 10 problems. Clearly basic derivative formulas will have parts A, B, C, let's say, right? So basic derivative, you must have at least one basic derivative that has E in it, like e to the x squared or e to the 3x or something like that. You must have either product or a quotient rule. Chain rule will be featured in at least 3 different problems, right? Very important. Implicit differentiation can be combined with related rates, can be with logarithmic differentiation and the tangent line, right? So a lot of these can, the derivative that you take for tangent line can cover any section, right? You can do the tangent line on the product rule, you can do the tangent line on the quotient rule, you can do the tangent line on logarithmic differentiation. So there are many opportunities for you guys to take different types of derivatives to find the tangent line at the end. So these are the list of topics, and now what are your questions?
Can you give an example of one on the tangent line?
Okay, what's your function?
Pick one.
Find the tangent line for what function? F of x equals what?
Do trig function.
Yeah, which one?
Sine.
Sine, okay, of what?
X.
Sine of x cubed
Plus 3.
plus 3
In parentheses.
in parentheses. All right.
To the 4th power.
that thing will be the death of us to the 4th power. How can we make that exam where everything is to the 4th power?
Just give it the roll.
It started here in somewhere, and then right. Did you start it?
Yeah,
You started the 4th power, yeah. We have to provide the x value, and let me take care of the x value. So let's go with the cube root of pi over 2 minus 3 to the 4th power. All right. Pi is going to be pi over 3 over here. So cube root of pi over 3 minus 3. I just want to make it match, it's nicer. All right, so every tangent line problem, regardless what type of function you have, always starts with the derivative of that function. In our case, we have derivative of sine is cosine of x cubed plus 3 times the derivative of the inside, which is 3x squared plus, no, it's 3x squared. So the derivative is 3x squared cosine of x cubed plus 3. Good thing you don't have to find the second derivative, right? So now, m is equal to f prime computed at the value, which in our case is this. And I picked this because it will calculate nicely inside the cosine function. So what do I have? I have 3 times this cube root of pi over 3 minus 3 squared. Cosine of, and now I have, the plus 3.
Can we do that on the tabs too? If we think it's going to make too much noise, just kill it.
Now I'll give you pre-approved problems for the test. This is why you're supposed to be ready with questions. Well, why didn't you ask? We came up with this thing.
I was distracted.
Oh, you were distracted. You were distracted by the review.
Yes.
Okay. All right, so here we go again. So when I take the derivative, we have our cosine of x cubed and then 3x squared. So 3x squared. Okay, good. So now compute the slope by plugging in the x value provided. That's going to be 3 times cube root of pi over 3 squared times the cosine of cube root of pi over 3 cubed, and that's going to kill the cube root. That's why I picked it that way. So now we're going to have 3 times, and when I square this, it's going to be pi over 3 to the 2/3, because the cube root gives you divided by 3, right? And then we have a cosine of pi over 3. Cosine of pi over 3, because the cube root will be canceling the cube up there, so just have cosine of pi over 3. Now, cosine of pi over 3 is very good, and that gives us 3/2 of pi over 3 to the 2/3 to be our slope. I know it's not pretty, but that's the function you came up with instead of looking up one in the book. So now we need the y value for our calculation, which will be original function raised calculated at cube root of pi over 3, and that's going to be our sine of cube root of pi over 3 cubed, and that's sine of pi over 3, which is root 3 over 2. Y equals mx plus b. Y is root 3 over 2. M is 2/3. No, 3/2. 3/2 of pi over 3 to the 2/3 times x. X is the cube root of pi over 3 plus b. Now, we can make this much better. 3 over 2. If I write this as a cube root of pi over 3 squared and multiply it by the cube root of pi over 3, you see what happens, right? Pi over 3 squared times pi over 3 becomes pi over 3 cubed, and then cube cancels the root. The rule was root a times nth root b is nth root ab, so we can combine them. So this is a root 3 over 2 is equal to 3/2, and now you have a cube root of pi over 3 cubed, and this is where they cancel. Oh, I forgot plus b. And we have cube root of 3 over 2 is equal to 3/2 times pi over 3. Now these guys cancel. Plus b, and from there you have your b as a root 3 over 2 minus pi over 2, which you can combine into root 3 minus pi, everything over 2. So it simplifies nicely, at least. Y equals, the slope is 3/2 cube root of pi over 3 x plus root 3 minus pi over 2. That's the tangent line. Should have picked the better problem, huh? It doesn't matter what the function is. It doesn't matter which point you are computing it at. It's always the same procedure. You first find the derivative, then you plug in the x value into the derivative to get the slope. Once you have the slope and x and y value, plug into y equal mx plus b to calculate b, and then at the end, write the tangent line. Yes? So logarithmic differentiation question is next. y equals 2 log base 3 of x to the 4th minus 2. We are looking for dy dx. We're looking for the derivative. Log base 3, yeah. So if you forgot the formula or didn't get to it yet, the derivative of log of base b of some function is f prime of x divided by f of x times ln b. So dy dx, which is x to the 4 minus 2, times ln of the base, which is ln 3, and the derivative of 4x cubed goes on top. You can combine the constants into 8x cubed divided by x to the 4th minus 2 times ln 3. Now, what I need you to see is that this is your f of x, right? The one that are taken right there. And as you can see, it appears cut and paste in the solution. So f of x, Control C, Control V, put its derivative on top, and then times ln of the base in the denominator. Any other questions, concerns? Yes? Any other questions, concerns? Yes? Another one?
Yeah.
Which one?
Another question that's like this. Yeah, like this one, like 6 log 4.
Y equals 6 log base 4 of, let's go, sine cubed of x, because we can. Try it. And I'm going to actually put up the orange formula.
Oh, there's some.
He's battling.
I'm summoning the forces.
Second.
This one is a little bit pricey, right? This one has a double tangle, but it shouldn't be impossible.
I'm waiting to see a picture of the dog. That was my dog.
Let's take a look at the solution. So the derivative of function y in respect to x is going to be, we copy 6 because that's just a constant. Since it's a log derivative, we immediately put the division and copy the function exactly as is in denominator. Nothing fancy. We take its derivative as 3 sine squared x times cosine x. So we have to take the derivative of sine cubed. Well, that's like x cubed. And derivative of x cubed would be 3x squared. So this is going to be 3 sine squared. And then, because it was chain rule with the sine, the derivative of sine is cosine. And we still have to put ln 4 in here. A lot of cancellation here. Sine squared cancels with 2 of the sines downstairs, right? And what we have is 6 over ln 4 as 18. 3 times 6 is 18 over ln 4 times cosine x over a single sine x that survived. And that's 18 over ln 4. Cosine over sine is cotangent x. So 18 over ln 4 cotangent x. Anything else?
And sine x plus cosine x over e to the x. Yeah.
The derivative of sine x plus cosine x divided by e to the x. This is going to be quotient rule because I have division, right? And that is e to the 2x because I have to square it. E to the x squared, 2 times x is 2x. Now we put e to the x times the derivative of the numerator. Derivative of the numerator is cosine x minus sine x. Minus, copy the numerator, which is sine x plus cosine x, and then derivative of the denominator is still e to the x. Now we will put e to the x common factor, and I'll have cosine x minus sine x from the first parenthesis minus sine x minus cosine x from the second parenthesis. This minus will distribute to both, and that's how cosine becomes negative. Everything divided by e to the 2x. Now the e to the x and the 2 over here will cancel, so you're canceling one of the two e to the x's in the denominator. And also, you will have cosine minus cosine to give you 0. So what's left is negative 2 sine x divided by single e to the x. We can't simplify this anymore. Just leave it there.
So we can or we can't?
Cannot. There's nothing else to do. Yes.
It's another derivative question. Y equals 7 parentheses 8x squared. Ax
Y equals 7.
parentheses 8x to the second power plus 1 close parentheses to the power of negative 8.
Oh, so this would be the chain rule.
Yeah.
So what do we do? Try.
Take the derivative of the outside.
Excellent.
So it would be negative 56.
Excellent.
Then you copy everything the same. Minus 9.
Yes, minus 9. Very good. Because it's minus 1. Minus 8 minus 1 is minus 9. Then?
Then you have to take the derivative of 8x squared, right?
Which is
16x.
16x.
And then
So what's 56 times 16? All right, so here's the way you compute this without a calculator and without doing the 56. 16 can be written as 2 times 2 is 4 times 2 is 8 times 2 is... So all you need to do in your head is double 56 4 times. So here we go. 56 doubled is 112. 112 doubled is 224. 224 double is 448. 448 doubled 896. That's how you multiply by 2, 4, 8, 16, 32. You keep doubling. It's fairly easy. Oh, I'm going to place this in the denominator now because it has negative exponent. So negative 198, well, divided by 8x. It's too hot. I can't speak. Over 9. We're good to go. Get out. Second derivative. I'm gonna bring a special exam just for you on green paper. Every derivative is 8 derivative inside. And all functions to the fourth, obviously. Yeah. Find the 8th derivative of to the fourth. Any other questions?
Does sine 3y equals x?
Sine 3y equals x.
And then find the slope of the curve at the given point, which is 0 over 3.
Ooh, we have a tangent line problem over here. Guys, this is an exam grade question. Easy. Easy. Right? It's not complicated, and it's going to use basic implicit differentiation. So, the derivative of sine of 3y is 3 cosine 3y dy dx equals 1. We have that y is... What happened?
Why does the 3 come out front?
The derivative of chain rule from the 3y. Right? You have a couple of those formulas where the derivative of e to the ax is ae to the ax. The derivative of sine ax is a cosine ax.
But is that cosine or sine cubed? That's not sine cubed, right? That's sine times 3.
3y, yeah.
There are also times where it's just like the x is just the x. What is that?
So now, when I plug everything in, becomes 3 cosine of 3 times pi over 3 times m is equal to 1. 3 is cancelled. 3 cosine of pi times m is equal to 1. How much is cosine pi? No. There we go. So, m is equal to negative 1/3. What? Where? Alright. So, we have y equal mx plus b. We have pi over 3, that's y. M is negative 1/3. X is 0 plus b. B equals pi over 3. And, oh, I'm so, this is already the y-intercept because it's 0 comma pi over 3. I don't know why I wasted my time. My brain is shut down. That's it. I'm done. This calculation was really not necessary because we already have 0 comma pi over 3, which guarantees that it's a y-intercept, right? Which is b. Anytime your point up there is a 0 comma number, that's b. 0 comma b. In all other cases, you have to compute. It's just, yeah. Oh no, it's falling apart. The top layer is trying to fly away from the bottom layer. You should press it. Any other questions? That was a good tangent line problem.
Y equals x minus 23 over square root of x minus square root of 23.
Y equals, is this good so far?
Yeah, it's going to be square root x minus square root of 23.
Like this?
Not a square root x.
No, 2 separate square roots.
It's 2 separate.
Root x minus root 23.
And what are you supposed to do here?
Just find the
Just find the root. Okay. So dy dx.
I'll go on.
Okay. So
I remember this question, they had told us to simplify the before finding the derivatives.
I was about to say, should we rationalize this to make it easier, right?
Yeah.
So we'll multiply by root x plus root 23 and root x plus root 23, which would give us x minus 23 times root x plus root 23 divided by, and this is difference of squares, it just becomes x minus 23. And that cancels. So now dy dx is derivative of square root of x is 1 over 2 root x. And derivative of root 23 is just 0 because it's a constant. Now I would consider that fun, but I don't know. Try to do the quotient rule on the original problem and see it simplifying to this.
Couldn't you factor out the top and
Yes. But very small percent of people sees that. So the answer is yes. To factor the numerator. It would factor over the... That's the boss trick. You factor the numerator, it becomes root x minus root 23 times root x plus root 23, and you have in denominator root x minus root 23, and these guys completely cancel, and you're still left with this. So whether you are rationalizing or you factoring, is you have to end up with the same. Anything else? Yes. A lot of things within this. Can you be more specific? So the two very important inverse trig derivatives would be inverse sine and inverse tangent, where inverse tangent is more important than inverse sine a little bit, right? So those two are absolutely must know. The other four, not as important. So the formula for inverse tangent of a function is f prime of x divided by 1 plus f of x squared. That's the formula. So now, if you have an example to find the derivative and later maybe tangent line or whatever of inverse tangent of, let's say, 3xe to the x, just to make it worse, you would have to say 1 plus, and now you have your function, which is 3xe to the x. You will have to square that, because the f of x has to match the f of x. That's what f of x stands for, right? So it's the same f of x. And now you take the derivative of f of x, but when you take the derivative of x, right, you see it's a product rule. Very good. So, product rule. Copy the first, 3x. Derivative of the second is e to the x, plus copy the second, e to the x, times derivative of the first is 3. So this would simplify into, factor out 3e to the x. What's left is x plus 1, divided by 1 plus 3x e to the x squared. And you can leave it there. Better than if you write 9x squared e to the 2x. It's just, we don't care about denominator, because in chapter 4 you say equal to 0 and then cross multiply, so the only solution is negative 1. Happy?
Oh my god, that door just opened, bro.
Yo,
Paranormal activity.
What happened? The door?
The door just
Exercise
opened.
this room.
Yes.
Get some holy water in here.
Alright.
Can you do a prayer?
Action. Do what?
Can you do a prayer?
We'll
What's
do
this
it.
class?
So, anything else? Let's take care of more calculus first. Yes. Sure. Tangent line with the inverse trig. Woohoo.
I have here the f of x equals inverse sine of x over 4 at the point of 2.
Formula for derivative of inverse sine of x is, did anyone remember? 1 over square root 1 minus x squared. If you want the f of x version, sine inverse of f of x is equal to f prime. Yes, exactly. I will rip it apart.
Goodbye. Drive safe.
So we have our formula function to be x over 4. So dy dx, the derivative, is equal to square root of 1 minus x squared over 16, and then the derivative of x over 4 is just a quarter. To find the slope m, we will plug in 2. We'll plug in 2. So this becomes 1/4 over square root of 1 minus, and now it's 1/4 over here. And then we compute this. So what do we have? We have 1/4 divided by the square root of 3/4, and the square root of this, so you have 1/4 over square root of 3 over 2. So m is equal to 2 and 4 would cancel. So, well, let's do the 2 divided by 4 root 3, which is 1 over 2 root 3. You can rationalize this into a root 3 over 6 when you multiply root 3 top and bottom to kill the root 3. So now m is this. So now what I'm going to do is I have my x and y, which are 2 and pi over 6, if I remember well. So y, which is pi over 6, is equal to m root 3 over 6 times x, which is 2, plus b. This is going to be, I already have common denominator of 6, so I'm not going to cancel. I'm just going to say pi over 6 minus 2 root 3 over 6 is b, so that I can have b as pi minus 2 root 3 over 6. Y equals root 3 over 6 x plus pi minus 2 root 3 over 6. Nice. Yeah, these are all the tangent line questions differ only by what type of derivative you are taking. Is it e to the x or sine x or x squared or inverse sine, right? It's just different type of the derivative procedure is always the same. Find the derivative, plug in the value, right? It's always the same procedure. Yes. Sure. Free of charge.
F of x equals x squared minus 8, parentheses p, parentheses 5, comma 17. Yeah, like it's like the question.
P?
Point P is 517.
Yes, okay, good. They want you to use the limit definition. They want you to use limit definition to calculate the slope of the tangent line. So we have to create f of x plus h first, and that's going to be x plus h squared minus 8, which is x squared plus 2xh plus h squared minus 8. And now we plug everything in. Limit h goes to 0, and we have x squared plus 2xh plus h squared minus 8 minus f of x, which is x squared plus 8 when you take care of the negative sign. So now x squared dies, 8 and 8 dies, and we have limit h goes to 0. You can factor out h, and you get 2x plus h divided by h. Now these guys will cancel, and you will get, when h goes to 0, you will get 2x. Just the derivative. You know the derivative of x squared minus 8 is 2x. This was the long way to do that. And now you plug in, so you know the drill. Because f prime is 2x, m is f prime computed at the point they are interested in, which is 5. So that's going to be 2 times 5, which is 10. The other point is 17. So 5, 17 as a point. So 17 is equal to 10 times 5 plus b. And then you have b is 17 minus 50, which is negative 33. So tangent line is y equals 10x minus 33. I hope.
Wait, what's the score for passing?
Some quick quiz.
70, 70.
Yes!
Any other questions?
When are we going home? We can choose, right?
Wait, when are we going home? Like today?
We're not
Class is over 3 minutes ago, but we can still squeeze an example.
Hey.
You got a couple of questions you want to ask?
I'm out of holy water.
Paper.
Wait, a lot of holy water? How much? Like, when is it too much to have holy water?
Wait, so you're not?
Too much.
Yeah, like, is there ever a point that
You don't have
to
to drink it. You're supposed to be.
Alright, so exam is Monday. Make sure you don't miss it.
Bro,
Wait,
I don't
exam
get
what?
holy water.
Me too.
Monday.
Tuesday.
How else are you supposed to?
Tuesday.
Oh wait, no, I'm thinking orgo.
Alright.
I'm thinking name of
Bye.
Scared the shit out of me. Yeah, my orgo exam.